At Parasite ID, our mission is to empower programmatic decision makers in the struggle against neglected tropical disease by automating key parts of surveillance data collection and reporting, thereby increasing the effectiveness of NTD control and elimination efforts. In collaboration with our research partners at PATH and the College of Public Health at the University of the Philippines, Manila, we have created AI-enabled digital tools to streamline soil-transmitted helminthiasis and schistosomiasis surveillance data capture and reporting. The current World Health Organization recommended process to collect and record measures of soil-transmitted helminth infections or schistosomiasis is highly manual and subject to understandable human error. To assess infection, microscopists must first be able to accurately recognize the species of any eggs present in stool specimens. Next, results are recorded manually on paper, and they are later aggregated manually to share with different levels of the healthcare system, where again, results from different locations are manually aggregated. This process is error-prone and not timely. What if the capture of estimates of NTD prevalence and intensity of infection were more accurate, timely, and visible to those who allocate limited resources to those most in need? Our interdisciplinary team is composed of public health researchers, user experience experts, implementation scientists, data scientists, software engineers, and other experts. We have engaged more than 70 stakeholders to build and test a contextually appropriate tool for surveillance data capture and reporting. To enable digital capture and reporting of soil-transmitted helminth infections and schistosomiasis prevalence and intensity over location and time, we have created an integrated set of tools. During field surveillance activities, egg species type is identified in stool using a mobile app enabled by AI. The app can transmit data to enable storage and aggregation of results by time and location in cloud databases, and data can be displayed in near real time in web-accessible dashboards. We've designed an adapter to enable robust attachment of mobile phones to microscopes. During surveillance activities, fecal samples prepared by World Health Organization guidelines can be analyzed by microscopy with the Parasite ID app. Surveillance microscopists can analyze samples to locate parasite eggs and use the app to capture and analyze images of parasite egg types. The Parasite ID app uses a deep learning AI model to accurately assign egg species types. During system evaluation, model performance exceeded the average microscopist's abilities. Importantly, the Parasite ID app works in the absence of internet connection and will function in locations without stable internet. The quantity of each possible soil-transmitted helminth or schistosome egg type per sample can be recorded in the app for transmission to cloud databases upon return to stable internet connection. NTD prevalence and intensity of infection data collected from the mobile app can be summarized and made visible to programmatic decision makers via web-accessible dashboards. This automated data pipeline allows accurate and timely data visualization that can empower highly informed decision-making. Unappreciated patterns of infection based on location and time will be revealed. Not only will this enable data-driven programmatic actions to be made, it will also enable assessment of progress toward the goal of NTD control and elimination. At Parasite ID, we firmly believe that what can be seen can be solved.